Hello and welcome everyone. I'm your host Stefan Burns, geologist, geophysicist with breaking news. Fuego Volcano in Guatemala has been furious over the past 24 hours. In fact, actually a little bit longer than that, but starting yesterday, August 3rd, Fuego started to have a significant eruption going all the way through today. It's simmered down just over the past few hours, but the past 24 hours has been nuts for Fuego Volcano. Fuego meaning fire in Spanish. This is a big stratovolcano located in Guatemala, fairly close to Guatemala City. And these lava fountains last night were 300 meters tall at certain points. So about 1,000 feet, which is very tall. This is at the very top of the volcano, which is about 12,000 feet tall or 3,700 meters approximately. It's actually a little taller than that. And this is all following up just about 2 weeks after a magnitude 7.3 earthquake struck off the coast of Mexico and Guatemala, just about 200 kilometers away to the northwest. So we've seen this connection between earthquakes and volcanoes before. This is well established. Often the biggest volcanic eruptions are preceded by very big earthquakes, that jolt of seismic energy, or if there's a swarm, which the Mexico earthquake did have in the days and weeks following, still pretty active, can really activate the magma plumbing system and the hydrothermal fluid system associated with these volcanoes and cause them, it seems, to be more eruptive and sometimes have these really big explosions. So we saw that very clearly. And there's also been some unusual weather, lightning, plasma, electrical activity around this part of the planet since the magnitude 7.3. That was on the 17th of July. So we had the magnitude 7.3, and then on the 19th of July, just 2 days later, we had a pretty significant just single explosion from Fuego that was pretty notable, caught people's attention. I was talking about that. We're going to discuss more the geophysics of electrical charge, positive charge accumulation at high points, earthquakes, and things of that nature. I just discussed that before, but now we really need to discuss it again. On the 21st of July, there was a crazy electrical lightning storm that was hanging over directly Fuego. There's been big activity since then. We got hit by a sequence of solar flares from the 20th to the 23rd of July, and the earthquake swarming was still going on off the coast from the 7.3. Then on the 23rd, you had Hurricane Genevieve in 24 hours, like all of a sudden become a pretty significant cyclone. In 48 hours, strengthened to Category 4, hit Category 5, becoming a super typhoon. That formed right off the coast of Mexico and Guatemala, where that seismic swarm was occurring. And now we're seeing renewed activity from Fuego in August 3rd, August 4th. So at least from my perspective, okay, everyone can interpret things differently, but it seems pretty cause and effect that one of the longest and strongest volcanic eruptions from Fuego Volcano in the past 10 years has happened just 2 weeks after the magnitude 7.3 that struck Chiapas, Mexico, which was a very notable earthquake. And to further add evidence to that, you had a huge eruption from Fuego back in June of 2018 that actually killed 200 plus people. It destroyed an entire village due to the pyroclastic flow. Well, in September of 2017, so 9 months before, you had a magnitude 8.2 megaquake strike the same location as the 7.3. So we see clear example there of how earthquake activity can set off notable volcanic activity nearby. So we're going to cover what's happening right now with Fuego Volcano. We're going to cover some of the larger geophysics at play as it relates to where we are seismically with the globe and where we are energetically. This happened right as we were coming out of a G2 geomagnetic storm. So we've had a solar storm impact, and we've had notable earthquake and volcanic activity elsewhere, especially the volcanic activity Campi in Italy. Italy's supervolcano had a 4.7 magnitude jolt, strongest ever in recorded modern history. Just on the 31st of July, Mount Etna has been very active. Many other volcanoes are displaying tremendous activity. So yeah, we're in this increasing phase of volcanic activity. It's likely going to last a few years because what we see is that you get solar activity to come in that charges up the Earth, and then once it starts to pull away, once solar activity starts to decline, that's when you see earthquake and volcanic activity respond and increase. And the fact that we've had so much earthquake and volcanic activity during the active phase of solar cycle 25, the maximum phase, now we're at the beginning of the descending phase. The fact that we have had so much activity there does not bode well for when we finally do get to the minimum phase, because it's probably going to be even more. I doubt we're in an out of phase relationship. So it looks like we're going to be going into some very active time periods, like this year, but really going all the way to 2032 is when I expect there to be a lot of earthquake and volcanic activity. So hello and welcome everyone. I'm your host Stefan Burns, geologist, geophysicist, space weather guy. Let us look at our location here. So here is, of course, the Americas, north, south, central. This is the epicenter of the magnitude 7.3 right there. We'll look more at the earthquake swarming that's been happening and the 8.2 that struck in 2017, okay? But here is Volcán de Fuego. So a big volcano, and precisely it is 12,346 feet tall, which is 3,763 meters. It's a beautiful stratovolcano. You even see the ash here coming up in this Google Earth satellite imagery. I can kind of go sideways here for you so you get a sense of the topography very clearly. It's a very tall volcano. You actually have a higher peak behind it here. And a lot of people, they hike up here so they can then see Fuego from the side. So you'll notice a lot of videos of people that hike up there for a sunrise hike and they hope to catch Volcán de Fuego in the midst of eruption. We see that there have been pyroclastic flows that have gone down the slopes of Fuego. That is one of the things that's happened today, past 24 hours, is that we've had pyroclastic flows down the southeast flanks. So it looks like they've been going down this direction where they typically do, and people live on the slopes of this volcano. So there have been evacuations already, and Guatemala has put out a nationwide orange alert for what's been happening over the past 24 hours. So this is quite serious, and it's the second highest alert level that they have. Only alert level higher, I imagine, would be red, right? Orange and then red. So they're basically saying you need to make sure you have a 72-hour bug out bag and get ready to go, and they are already evacuating people that live close and on the slopes of the volcano to temporary shelters elsewhere. So this is a big deal. And you'll notice the location. There's actually a bunch of volcanoes right here because this is a subduction arc. So you get volcanoes with these subduction arcs where one plate is going underneath the other. Here, the oceanic plate going underneath, this section of Central America. This is actually the Cocos plate. But you also have this other tectonic boundary cutting in right here, and this is where it terminates into the subduction zone. Because if you look at the larger Caribbean plate, here it is. So interesting that we had this magnitude 7.2, 7.5 doublet that struck Venezuela on the 24th of June, the strongest doublet seismic sequence in general since 1812, and hugely destructive. Tens of thousands of lives lost. The official tally, I don't know what it is now. Last I heard was 5,000, but there were still tens of thousands of missing people in the directory that they created. So a lot of people never got pulled out, basically, from the rubble of the collapsed buildings. So you have this occur there, and interesting how at a critical junction for the Caribbean plate, just, about 3 weeks later, you have the 7.3 that struck Mexico, and now we are seeing Volcán de Fuego really just go nuts. So this is all connected together. as you can see, and that's because there's energy here that is releasing through the earth. We can see another video here of Fuego. This one taken here by Alex Dwar. I've linked all the credits in the video description. And so thank you to him for this video, but far off. And we get a bigger sense of the volcano with this footage. These lava fountains, they were going for multiple hours. So sometimes Fuego literally just does like an eruption like this, and you get one big show, and then it's over. And it's very active. It's one of the most active volcanoes in Central America. It's actually one of the most active in the world. But to have long duration activity like this, with lava fountains going up to 300 meters, is a different phase of activity. That's not, I mean, it's normal for a volcano, but it's certainly a huge increase as to what we've been seeing. And again, it's one of the longest and strongest volcanic eruptions that Fuego's had in the past 10 years, going back to the very destructive 2018 eruption that was on June 3rd. Here we have another video, this one from Lone Wilhelm, and really incredible activity. This is in the morning, okay? So it was really erupting at night, and it was continuing to erupt in the morning. We'll check the live feeds in a moment, but right now I think there's a lot of clouds. Maybe they've cleared up. But I'm reporting for you on this live. And yeah, we just see that this ash plume was gigantic. It went up about 7 kilometers, so it did not reach the stratosphere, which would be about 10, 11 kilometers up, but it did get up to about 7, and it spread out quite significantly. So Conred, which is the emergency service for Guatemala, has put out an alert. We can look at that. We'll cover that for earlier in the video. They are warning about this ash cloud here spreading to the northwest-west, and it's about 120 kilometers that's spreading out across, and there are concerns about, of course, air quality and any downstream effects of ash blanketing buildings and cars and clogging up things. And so they're recommending that you get a face mask and just ideally get out of the way, get out of the area, because this can be very, very well, it is toxic. It's just a question of how much you breathe in. So this is a significant situation that's unfolding right now. Here we see our earthquake swarm for Mexico, the 7.3. This is our past month of activity, and we'll put only earthquakes on the map here, so we really see this. And we see that we've had tons of magnitude 4s, and the last magnitude 5 is right here on the 31st of July. So there still has been some higher magnitude activity, but that's about 4 days ago now. Magnitude 5 there on the 30th. But if we go to highest magnitude, we see our 7.3 there. There's our 7.3. You see the swarm that resulted afterwards, the 6.4 aftershock, which makes sense. All the magnitude 5s. Look at all these magnitude 5s. Huge amount of magnitude 5. So this is obviously a very big geologic event that occurred. And we have tons of data across the world from a variety of earthquakes that have occurred of different magnitudes and locations and settings and more, of how do you get this strong positive charge to accumulate at the epicenter of an earthquake before, during, sometimes afterwards, that can modify the ionosphere. Earth's upper atmosphere, which is about 1% plasma, which is the fourth state of matter, or really we should call it the first state of matter, because plasma is when you have a molecule or an element and actually splits apart such that you have a positive and a negative charge carrier. So you have a cation and an anion. And as a result, they're now susceptible to the electromagnetic force rather than more so gravity. Because if it's a neutral particle, electromagnetism doesn't really affect it. It's neutral. But if it has a charge to it, especially electrons, they can quickly move under magnetic influences, and positive charges will generate strong electric fields. So what we observe is that often before earthquakes, we get these ionospheric disturbances, changes to the electron density of the ionosphere over the location, changes in the height of the ionosphere. And so a lot of research has been done into this, showing that if you get a strong enough electric charge field to develop, let's say in an area, it can actually alter the height of the D and E regions of the ionosphere such that that affects the electrical conductivity of the entire atmosphere in between the ionosphere and the ground surface, the troposphere, the stratosphere, the mesosphere, right, going up. You can alter that flow of electrical conductivity and just electric current, because the ground surface, typically we consider it neutral, zero volts. Whereas the ionosphere has an equipotential about 250, 300,000 volts. It can get up to 400,000 volts if there's like space weather influences and more, depending on the location. But by equipotential, I mean that's homogeneous. That voltage potential of 250,000 volts is spread out in general homogeneously across the globe, though there's variations in the polar regions, north and south. Now, what do these numbers mean? Well, in the United States, your wall outlet's 120 volts, okay? So that's the potential. Now, to drive something, you need current. So you're running appliances or whatever, right? Especially like a microwave, requires a lot of current, but you have this simple voltage. And the higher the voltage, if there is a current there, the more deadly it is, because it's just a stronger overall shock. So current is what kind of matters as it relates to like a discharge, but voltage is really important too. So your wall outlet, again, is 120 volts. Well, the ionosphere is 250,000 volts. And a lightning storm can be in the range of millions of volts, so megavolts. It can be 50, 100 megavolts. So we can scale up really quickly. Well, when you get the ground surface to change with its voltage, that affects the overall electrical conductivity, it influences weather systems, and affects the ionosphere. And well, it seems that this earthquake swarm, I mean, this is really what I would say. I'm sure there's going to be some people that just simply, they're not on board with this for whatever reason, but it's so clear that when you get this sort of activity with earthquakes, you're also affecting volcanoes, and there's this intermediary of basically the electromagnetic field of the area and plasma. And now you're working with bigger systems because you're going out to the ionosphere, which is influenced by solar activity, space weather, the plazosphere, right? So and we've seen with big earthquakes, these really long period fluctuations of Earth's magnetic field itself. For example, 1964 Alaska, they noticed these long duration gamma wave fluctuations. So like we know this all exists. It's just basically research, study up, and you see it, you know it. If you don't, then you scratch your head because you're still stuck at, looking at thin sections. So we had this big earthquake strike Mexico. And then on the 19th of July, we see this activity here from Fuego. So this was definitely a big explosion, but not long duration. But this really got people's attention. You can see it right there. Big explosion from Fuego on the 19th, just 48 hours later, right? So, I mean, again, cause and effect is so simple. And here we can now look at our weather map. Because if we go back, we will see, we're loading the imagery here, Hurricane Genevieve there form off the coast. I can only go back to the 25th of July, but if you were to go further back, Genevieve formed right around here. I mean, you can see the dots. It formed right around here. The epicenter of the magnitude 7.3 is right there. Fuego's right here, okay? So just 4 days after the earthquake, you get this monster cyclone to form. And look how quickly, blue stands for tropical depression, okay? Green is tropical storm, and purple there is category 5. So that's the 27th of July. So in the span of 3 days, you went from nothing and then a tropical depression all the way to a category 5 monster that then swept all out across the Pacific. So that is really, really, it's speaking to the powerful electromagnetic dynamics that were existing in the lower atmosphere after that magnitude 7.3. We also, if we go, I'm not sure how easy this will be to look through. We had this electrical storm hover over Fuego on the 21st. So here is that video, flashing light warning for those of you who are sensitive, flashing light warning. But this was directly over Fuego on the 21st of July. So, you know, further continuation of this powerful electric charge buildup, as you can tell. Now, if we go back to our first video here, watch the strikes. You see lightning striking all around. So there was a big lightning storm that was accompanying this eruption that has just happened for Fuego Volcano, August 3rd, and then today, August 4th. So there's been a lot happening. Now, after the 21st of July, we can look at our solar flux here, and we will see that there's more to this story. So let's look at this now. Here we have our X-ray flux, and we have a sequence of solar flares. As you can tell, these are big explosions on the sun. They emit light radiation, so normal light like you and I see, but we only see optical light. This is X-ray light, extreme ultraviolet light, very high energy. It instantly ionizes things. So it can convert a normal gas molecule into a plasma. So these solar flares that are popped off starting on the 20th of July, going through the 23rd, and Genevieve all of a sudden formed on the 23rd. So we already had this positive charge accumulation near Mexico and Guatemala, as discussed, because we had the earthquake, we saw Fuego have that big explosion, we saw the crazy lightning storm over Fuego on the 21st. Then you get some additional solar input. Some of these flares directly also ionize and cause radio blackouts over the Americas, okay? And then you saw Hurricane Genevieve become a monster by the 27th of July. That's also when you specifically had 2 more M-class solar flares pop off to really push it, perhaps, you know, it's adding in for sure, to that Category 5 status. Since then, things have died down, but now Fuego is showing just a few weeks after what occurred with the magnitude 7.3 in that last explosion on the 19th. Now it's having some of the strongest activity in a long time. Now let's go back here to our map, because here we have, again, our volcano and our 7.3, but let me turn on now the 8.2 that struck. So we have our 8.2 that struck Mexico, a little bit more to the northwest. Okay, a little bit more to the northwest, effectively the same place though. I mean, let's measure the difference in between. It's probably about 120 kilometers. Yeah, 120 kilometers. So, I mean, at the end of the day, not a big difference. But that was on the 9th of September, 2017. And again, the big eruption that was notable for Fuego in the past decade was June 3rd, 2018. So you had a 15-kilometer high ash plume from that. Pyroclastic flows killing 200 plus people. Heavy rainfall afterwards triggered lahars. So again, I've been talking about the electrical activity of the atmosphere, right? You have this big explosion, and then you happen to have really heavy rainfall. Now this area is tropical, so yeah, they're getting rain and lightning all the time. Okay, I've been to Costa Rica, and I've also been to Oaxaca, Mexico, so I kind of understand the deal. Though they do have a dry season, so that's not necessarily out of the norm. They are, of course, getting a ton of solar radiation because they're close to the equator. But the fact that there was this super heavy downfall after that eruption, causing even more destruction, right? You know, rain clouds are electrified, not as strong as a thunderstorm. Maybe there was thunder and lightning. I don't know for that. But there was super heavy rainfall that triggered lahars, destroyed an entire village. And overall, the eruption, June 3rd, 2018, affected 1.7 million people. So that is about a 9-month delay, right? With this 8.2 and then what happened in 2018. So 8.2 is about 30 times stronger in terms of energy release than the 7.3. So, I mean, now we have another example, and this is the biggest earthquake that struck this area ever in recorded history. So geologic history, no, I'm sure there's been equivalent and or maybe bigger. But in terms of our record of big earthquakes, this 8.2 takes the cake. So it's really quite notable. So Fuego is active, and this could just be the beginning of a new wave of extreme activity from Fuego. It could get worse. Again, the Colombian or the Guatemalan authorities have issued a nationwide orange alert as a result of what's happened over the past 24 hours. That is the second highest level. They are very concerned. Evacuations are already taking place, and we could see a lot more activity from this. Now, viewer discretion advised here. This is a flashing light sequence. It's quite strong. So if you don't have an issue with that, you'll be fine. But if flashing lights, they trip you out, this is the time not to watch the video. I'm going to show you some volcanic lightning from Fuego, because Fuego is well known for its volcanic lightning. And so this is just further confirmation and proof of everything I've been discussing. Now, this is not from what's been happening now. I don't know what time period this is from. And we get this with other volcanoes too. Keep in mind, because as you get the ash and the smoke and everything to come up, it's generating a lot of friction. It's localized electric charge buildup, which then arcs and discharges and creates plasma. But still, it's what's driving the energy up into the volcano in the first place. That's some pretty powerful electric currents there. So again, flashing light warning, but let us check this out because this is pretty wild here. So here we see Fuego, and it's having these massive lightning discharges, as you can tell. And these eruptions really, honestly, with this video, aren't terribly large. It's just clearly it's erupting. There's a smoke cloud there, but it's honestly, it looks like it's more plasma than, it being generated by some friction dynamics within the ash cloud. Because we've seen much bigger ash clouds and not seen these sort of plasma discharges. So very clear example of the connection between the atmosphere and the Earth itself, and specifically, atmospheric electricity and Earth electricity. All of these systems are interconnected. For some reason, there's just still resistance. There's still resistance in the modern mainstream for connecting the different Earth layers together. So this would be the magnetosphere, the plastosphere, the ionosphere, the different atmospheric layers below that, Earth's surface, the mantle, the core. Fundamentally, we know it's all connected together because, well, the magnetic field goes from the core of the Earth all the way out to outer space. But modern science, it's more scientism. It slices, dissects, and separates, and everyone's so hyper specialized that they kind of, they miss the forest because they're looking at the tree. So it's hard for them to kind of reach over and see the larger coherence of everything and how everything's connected together, the holistic, connection that everything has. So volcanic lightning, though, the observations that we have confirm, the truth of reality. We have to go by observations first, and then from there, we should be building our models, our math equations, and more. And a lot of people are doing that, so it's not everybody. But very clear example here of this volcanic lightning. So Fuego's been erupting like mad. And we could see a lot more activity from that in the days ahead. If we look here really quick, we have our page for Fuego here from Volcano Discovery. And if we look at our earthquakes over time, right here. Now, I don't know, there maybe perhaps was a lack of a distribution of seismographs or more. I don't think that's the case, though, because we see data points here going back to 1993. The thing to keep, I'm just referencing the fact that starting in the 80s, seismographs actually started to become easier to acquire and deploy because they were commercially available and more. So a lot of seismic networks have been built from the 1980s up to the modern day. And so you have to kind of take data from pre-2000 a bit sometimes with a grain of salt in terms of earthquake statistics, because maybe they simply didn't even have enough seismographs to capture in high fidelity all the earthquakes that were occurring. But it seems that we do have good earthquake statistics for Fuego because we do see this bump here in 1993. We had another bump here in 2013, 2014, but look at what happened in 2025. So huge activity from Fuego earthquake-wise in 2025 with 9 magnitude 4+ earthquakes striking the area, 74 magnitude 3+ earthquakes, And if we go down, we see that 2026, if this, I don't know how up to date this is, pretty up to date usually. 1 magnitude 4 in 2026, 4 magnitude 3 pluses. So definitely 2026 has been a reduction compared to last year, but now we're seeing bigger activity in terms of the volcano itself erupting, exploding, and more. So that's worth pointing out there. And let us now look at our real-time view. We have 2 different live streams here, one from Earth Lodge, Guatemala, and let's just see if we get anything from our live view here. Looks like just pretty heavy clouds over Fuego itself, so we're not really seeing much. But if you go back in time, you can see this lightning storm and you can see the eruption of Fuego. Okay, so this is this morning. That's local time, August 4th. And look at all the people that live nearby, right? Like, if this has a big enough eruption, you can get pyroclastic flow to, if you get even parts of the volcano itself, like a flank explosion, and an entire flank of the volcano goes, you could get massive pyroclastic flows going down into these valleys, causing widespread destruction, such that it makes 2018 look like just an appetizer, like child's play. But clearly there's just, for some reason, a big buildup of electrical charge happening in the Mexico-Guatemala region. Venezuela preceded, the Venezuela doublets, the 7.2, 7.5, they preceded the magnitude 7.3. I would say it's not necessarily the magnitude 7.3 earthquake that struck Mexico on the 17th of July being the progenitor of this electrical surge that's coming up. It seems to be more so a symptom of that. So that's happening right now, and as a result, if that 7.3 is more a symptom, a result of some deeper force that's occurring, then we could be looking at a lot more activity here. Here we have a graphic I want to show you. And this is basically showing how charge can accumulate from stress that is within the Earth, and then how that manifests in terms of observations that we make. So this right here is a great example, because here we have subduction occurring. Like, this literally could be right off the coast of Guatemala. We see that charge accumulates at high points. So you get this positive charge accumulate at high points. As you get this strain to accumulate, you get this piezoelectric effect, where strain physically deforming crystal structures causes there to be electric current to flow out. You have electrons that flow out, but then you also have what are known as p holes, or these positive holes that radiate out upwards. N-type crust, which is lower down, about 35 kilometers down or so, that is a type of semiconductor that is much more conductive, because you have these abundant electrons. And then you have p-type crust, which is more resistive up top, and that's where you get these positive holes, or p holes as they're called. So this positive charge accumulates. This can also drive earthquake lights, because you can actually just simply, you're ionizing part of the air, which is very, very dense in the troposphere, right? We talk about the ionosphere having plasma, but it's actually very low density. Where we are in the boundary layer, it's very dense. So if you are able to ionize it, you can actually generate a lot of plasma. And so often before these earthquakes, or during them, usually during them, we see these big flashes of light that just go straight from the surface up straight into the atmosphere. Feasibly, it seems, going to the ionosphere, because now it's so energized, gravity is not the main player, right? It's the electromagnetic force. So it shoots straight up the field lines, following the magnetic field to the ionosphere, maybe even the plastosphere. So we get these effects, and you can also have electric charge running through rock layers, inducing a reverse piezoelectric effect. So you have the electric charge moving through the rock layers that have a crystal mineral structure to them, and that then causes there to be mechanical deformation. So it's both systems simultaneously. Behind me, you see how a cloud has this negative charge that accumulates, It then shoots these lightning strikes down, these plasma bolts down, these arc discharges. The electric potentials are so huge. We're talking megavolts again, that it creates this channel, this ionized channel, and then immediately generates plasma and fills it in as it reaches for the path of least resistance and then discharges. So you see how that occurs, and here we see the ground surface has this positive charge. So no surprise that with big earthquake activity, big volcanic activity, we also see big lightning storm activity for the area. And yeah, here you can really see it popping off. Now, this is not right now. Again, this is going back to early this morning, but 300-meter tall lava fountains from Fuego Volcano, tons of lightning activity. Right now, though, if you look at our live stream right now, just some clouds over, and it doesn't seem to be doing anything at this moment, though we could very well see it ramp up in activity again at any point in time. Fuego, if you're aware of it, you've been watching it for a while, whatever, you know that sometimes it's just like boom. It's so sudden at times. So this is happening for Fuego. We also have this live stream here. If we go further back, we'll see some activity from it. It was showing up earlier. Here we go. So this is more zoomed in of the slope, as you can tell. And so some ash coming up, but this live stream is not that great. It's kind of jittery and slow. But that is the summit of it directly. And if we go live, we see that we're just seeing clouds right now. So those are our two live streams that I can point at. And again, as I mentioned earlier, but I'll show you, we just got out of a solar storm impact. So this came in on the 2nd of August, as you can tell right here. We have our magnetic field of the solar wind, and we see this sudden increase in that, and it also has these nice southward components there. What that means is the solar wind connected nicely to Earth's magnetic field, injected plasma into our plasmasphere, and drove stronger electric currents in the ionosphere, which is what I've been talking about, which induces electric currents in the ground surface. That's the electric currents in the ionosphere that actually drive the big swings in Earth's magnetic field that we observe at the surface. So there are changes happening at the magnetopause about 5-6 Earth radii out from the planet. But in terms of the big magnetic field swings that we observe with our magnetometers located across the globe on the surface, it's the electric currents in the ionosphere that are driving these big 500 nanotesla, 1000, 1500 nanotesla swings. So we see we have this G2 impact. I was actually surprised it wasn't a little stronger because we had plenty of periods there where we were in good connection, but we did not get to G1 levels again after this. This was a G2 minus 3-hour burst right there. That's because our velocity on the storm was pretty low, only 300, 400, about 400 kilometers per second and less. So velocity was quite low on this one, but still we had this. I forecast this back on May 27th. I said there was very likely going to be enhanced solar activity space weather. It's exactly what happened. That was on May 27th. Came in, and so this certainly did charge up the ionosphere more because we also had a S1 radiation storm, so high energy particles that blasted off from that explosion, hitting Earth within about 30 minutes, charging up the ionosphere in the polar regions. Those electric field changes propagate out more globally, but the high energy particles are primarily coming in the polar regions because they follow the magnetic field. So it's been very active, as you can tell. The past, really going back to Venezuela, I mean, it's actually been very active for all of 2025 and 2026 in terms of earth changes, earthquakes, volcanoes, space weather, solar activity, and more. But we're seeing that continue effectively. We're seeing it continue. It's staying very, very active. Now, before I sign off, I just want to let you know that I have a website where you can track some of these changes that are occurring with our planet. So we have some live data feeds here. This is earthevolution.com/energy-analytics. So we have our real-time Schumann resonances here, our global seismic activity level. You can see the earthquake activity. This is the 7.8 that struck the Philippines. This is our doublet that struck Venezuela, our 7.3 that struck Mexico, and other magnitude 6 earthquakes that have happened. So you can see it's been very high overall. Pretty good stretch, though there have been moderate and low days in between. So that makes sense. Our real-time radiation belts and some views of the sun show up here as well. There they are. So some real-time views of the sun and more. So I'd bookmark that if you're interested in this. If you want to learn this, you really should be checking the data daily or at some frequency that makes sense to you. Also, I want to point out, I have a website where I sell a variety of holistic wellness products, also some merchandise. So this is earthevolution.com/store. And we are running a new promotion till the end of August 12th, which is the total solar eclipse. And that is on our herb coffee here. So our herb coffee is a coffee blend. It's 50% coffee. It's 50% herbs and lion's mane mushrooms. So this would be single origin, organic, shade-grown Peruvian coffee. That's 50%. In addition to chicory root, dandelion root, and lion's manes, all organic ingredients. The promo is 12% off using the code YAYCOFFEE. So YAYCOFFEE. All one word, YAYCOFFEE. It's linked in the video description. You get 12% off. And keep in mind, this is a new larger size. So we originally had an 8-ounce size that was smaller than our 12-ounce, and it was also at a lower price point, but the overall price per ounce we reduced when we bumped up our size to 12 ounces, and now we have this new 12% code just for the herb coffee going to the 12th. So this is from Peru, pretty close by, really good coffee, and this is the stuff that I would drink if you maybe get a little charged up by the solar energy too much, because the chicory root, the dandelion root, the lion's mane is really good for you. Helps balance out some of the effects of the caffeine from the coffee. Effectively, this is half cap. But I wanted to alert you to our new promo, 12% off our herb coffee going to the end of August 12th using the code YAYCOFFEE, all one word. Apply that at checkout only for the herb coffee, just FYI. So with that said, I believe I have covered everything that I really want to cover at this point. So let us do a quick question and answer, and then I am going to sign off. We have some super thanks that have come in. I'll also go to the general chat afterwards, so you can type your question in there. But let's start off with some of our super thanks here. And Scott is asking, does the waning strength of the magnetic field affect volcanic explosion magnitude or anything else worldwide? Is Fuegan magma silica rich? Yeah, it's going to be silica rich because it's a stratovolcano. It's built up that cone. You don't build a cone like that with basaltic and in general more mafic magma. You need it to be really felsic, which is more silicon based. So yeah, and then as it relates, I think that's what you're asking about the magnetic field. Does the magnetic field waning in strength affect volcanic explosion magnitude or anything else worldwide? Well, the anything else worldwide is a huge 4-hour lecture for you. And I already have a whole playlist on Earth's magnetic field, which you can check out. So let's go to my playlist tab and watch those videos. As it relates to volcanic explosion magnitude, I'm not sure we can say anything definitive there. We do see some evidence of when we are having lots of magnetic excursions, reversals, more so reversals, it seems, from what I've seen with the research, that there's increases in volcanism. But in terms of just the magnitude of an explosion, I would put more weight on what's happening regionally with that volcano or volcanoes than the magnetic field. But the magnetic field affects effectively everything to some degree. Question is, what degree? And it's certainly not like the end-all, be-all factor. Some people put everything and the world on the magnetic field and what it's doing, and that's simply just not right, in my opinion. German, what do you believe is about to happen? Look what is happening in Southeast Europe with the Danube. That seems to be another big question about just what's happening in general. I've talked about that. Earth electrification is my larger view. We have a planet that's rapidly warming, but in addition to that, it's becoming more volatile with its weather and its climate and temperature swings and more. But huge amounts of energy have been absorbed into the oceans, as well as carbon dioxide, and we're having changes to oceanic circulation, changes to atmospheric circulation. But overall, what we're seeing is just greater and greater Earth electrification. We're having more of these sort of powerful, cyclones, right? Because that's all electrified, super electrified. It's the strongest storms on Earth, right? And earthquake activity is connected into that. So I think the bigger thing here is recognizing that, the universe is electromagnetic in many ways more so than it is gravity. And we need to take that into consideration as it relates to geology and geophysics. Because if you just stick with the old models of just weight and pressure and more, it's not going to fully encapsulate what's happening. As it relates to Europe and the Danube, I know there's been big droughts and everything. That's all connected into that. So also sometimes extreme flooding. So it's just more volatile in general. Where that ends, I don't really know. Stuart, Jason, thank you for the super thanks. Much appreciated. Barbara, thank you as well for the super thanks. Tamala, thanks for the super sticker. And a question here from Real American Honey. Thank you, or not a question, just a thanks. So thank you so much. Much love to the Gallagher clan as well. And there is a solar eclipse next week, and there's also a meteor shower the same day. So we have the Percy meteor shower peaking on the 12th of August. We have a total solar eclipse that's slicing across the very northern part of Siberia, Greenland, Iceland, and then through Spain, ending over Majorca. That is on the 12th. And yeah, there's actually quite a few things converging around August 12th, which is interesting. So yeah, a lot happening there. If you go to our, here's another one actually, just came in. And I was wondering, apart from Campi Flegrei, are there other supervolcanoes showing increased activity to keep an eye on? It doesn't seem so, at least top of my mind, like just right off the top of my head, I don't think so. Campi Flegrei really seems to be the big one to be concerned about. Because Yellowstone seems to be normal as of right now, and other supervolcanoes, I haven't really seen any reports coming in of them being abnormal in any way. So yeah, that's a good question though, but I think that's probably correct. So thank you for the super thanks. And Mark, thank you for the super thanks as well. Oh, another one here from Bernard. Thank you for the super sticker. Very generous. Much love. Thank you so much. And Nikki, the resistance to holistic science, in fact, is resistance to truth. Same spiritual dynamic, bro. I agree. Yeah, now, holistic science isn't going to, of course, be 100% right with everything, but it's you see the observations, you develop the best hypotheses, and maybe even get some theories that are, pretty good at predicting what's going to happen. But then as new observations come in, we will update these ideas. And that's in general the scientific method. The problem nowadays is that so much of science, if you want to put it in quotes too, science is done with just like modeling. So they'll just create their own set of parameters and use that to perhaps explain something, or even build models off of models, and then that's now what we're using to drive, like to explain what's happening with the Earth, rather than going based off of observations first and building models off of that. I mean, it still exists to some degree, but it's starting to get disconnected again. And to be an expert with models and data analysis and statistics and more, you probably don't know the base science that well, right? Because everyone's so hyper specialized now. So, I mean, a lot of people talked about this. I can't say this from any authority standpoint, but this is just what I see, and I think it's an issue. Geraldine, thank you for the super thanks. Big supporter of the channel. Awesome to see. And just going through some questions that popped up in the regular chat here before I sign off, and we'll see what we got. Just looking. Often we don't really get any in the regular chat. or a lot of them will just be super off topic. So I don't click them and talk about them because it just doesn't make sense. This is a bit of a third rail, but I'll touch it for just a second. Earth's response to the use of directed energy weapons. What? Yeah, a lot of people talking about like HARP and some secret Antarctic laser or whatever. Personally, like I've studied into HARP. I released a video on that a long time ago. Like I've done the research into HARP and everything. There's a lot there. I think that maybe 5% of that's true, and 95% is just bogus nonsense. So I'm not one to really, you know, I explore into the conspiracies and these other alternative ideas because there is truth in, you know, it's spread out. It's not all just in one area. You have to explore and have an open mind to really discover the truth. But I think 95% of that at least is probably bogus nonsense. Maybe but just like weird ideas and it's kind of culty and more. So, you know, if you have some laser, right? Lasers just travel straight. How can you have a laser at Antarctica to then hit a different part of the globe? Because lasers travel straight. So it's not a laser. So some of the basic physics people don't understand. So it doesn't make sense, you know. And what's powering the laser? You're going to need a huge nuclear power plant. Like I went to Ukraine, I went to Chernobyl, and they had, you know, running. They were going to have 8 reactors at Chernobyl, and they had the massive Duga radar installations that they were using the Russian woodpecker to cause signal interference and also missile tracking during the Cold War. They needed to run those things off of nuclear reactors, and not just one, but multiple, because these are massive megawatt installations. Half of it's still up there, the other half's been taken down, and it's like gigantic. So, you know, you need the energy to do it. And so if you don't have, you know, nuclear power plants there, you're not running in. There's no nuclear power plants as far as we know in Antarctica. It just doesn't make sense. And the whistleblowers have come out have all been kind of nuts. Like they just simply don't make sense, and they're nutso. So we haven't had a good real actual whistleblower or anything. But hey, you can make up your own mind, your own research, have your own thoughts and opinions. But if you kind of asking me, that's what I think. So see what I'm saying about some of these questions being a little out there. But you love them. It's fun to research into them and just explore into them. But I don't see really any that are coming in that are on topic. So thank you all, everyone, for joining in today on this live stream. I will keep you up to date on what's happening with Fuego. Big activity over the past 24 hours. It's very likely that we see more from this. It perhaps even reaches a new level. Orange alert has been issued by Conrad, the Guatemalan authorities, and they're really watching this closely. Ash bloom has been going out. Ash is going down over the next 12 to 24 hours. But we hope we don't see a big eruption like we did in 2018. Or even larger. We could get it, you know, these volcanoes fundamentally, eventually they really go. Like you'll get a big flank eruption like Mount St. Helens. Like this is tame compared to what it could do. It all depends though on the pressure that's been building up and whether it's just now is the time. So if we see more signs of that, I will be back with another video update for you. I also post updates on my X account at Stefan Burns Geo in between videos. So definitely go there if you want to stay up to date in a more real-time way. But I got you all here. Thank you all so much. Please smash that thumbs up button, help the channel grow. Subscribe to stay up to date. Wishing you all well. Have a great day. I'll see you all in the next video.